Hello, ladies and gentlemen, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be giving you kind of a brief overview of how climate works. Yes, this is very simplified, but it's all you really need to know for this class. So, what's the difference between weather and climate? A lot of times people use it interchangeably, and so here is the big difference. Weather is something that changes extremely quickly, and it is pretty much just what you see out your window or what you see when you walk outside. It's the day-to-day condition of the Earth's atmosphere. And like I said, because it's going outside, it changes pretty quickly. You can have a storm roll in within, minutes. It can start to rain and hail. And so that means that, the weather is not something that's very consistent. It changes all the time. Climate, on the other hand, is the average weather condition of an area over the course of a longer period of time. And so it changes extremely slowly. So here's an example. This is the temperature of the water off the coast of Los Angeles in Fahrenheit by month. So you can see there's only a 10-degree Fahrenheit difference between the beach in January and the beach in August. And there's a pattern. It slowly increases and then it decreases until it goes back to pretty much the minimum again. And that is pretty consistent. So that doesn't mean that if you go into the beach in January, it's going to be 58 degrees. It just means that's the average. So there might be some days where it is 68, degrees Fahrenheit in the ocean off the coast of Los Angeles in January. But the amount of days where it is cooler is definitely a lot more prevalent. And so it averages out. Here's another one. Here's the average of all of the annual temperatures in Los Angeles from 1878 to 2008. So you can see that even though we have this, you have these big peaks, that there's pretty much an average between the minimum and the maximum over the course of the entirety of this graph. So that doesn't mean that, it wasn't really cool for, a couple of the points on this graph, and it wasn't really, really hot for some of these points on the graph. But what it does show is that there is a pattern, there is a gradual increase if we were to graph them over time like this. Okay, and that's climate, because it's a slow change that we're looking at over the course of a long period of time. So what are the three factors that affect climate? The first is called the greenhouse effect. Now, the greenhouse effect gets its name because of what the greenhouse effect kind of is representative of, right? And so if you've ever been inside of a greenhouse, that's kind of what the greenhouse effect is trying to get at. Greenhouse gases are things like CO2, water vapor, and CH4. These are not the only greenhouse gases, but they are pretty much the major players. And they're in the upper atmosphere and trap heat from the sun. So you can see this is kind of like our band right here of atmosphere, and there are greenhouse gases spread around inside of this. And so when the greenhouse effect is being described, what it's kind of describing is the fact that energy from the sun is going to go, and it's going to go through the atmosphere, and it's going to hit the surface of the Earth. And then if the Earth were completely reflective, it would just, kind of bounce back and go into space. But because we have these greenhouse gases, as it reflects away, sometimes it hits greenhouse gases and it gets radiated back to Earth. And as it gets radiated back, that can happen hundreds or thousands or millions of times. And as that happens, the Earth kind of maintains this band of heat in its atmosphere. And without the greenhouse effect, the Earth would be way too cold to actually support life. So greenhouse gases are not bad, they're just not good in very high quantities. So next, latitude. All right, so big misconceptions here too. Latitude. So the latitude on Earth affects the temperature that you're going to be feeling. And that's because at the poles, we get relatively little kind of sunlight. Or I guess I shouldn't say little sunlight, because during certain portions of the year, they get ridiculous amounts of sunlight. But the idea is that as you go up or down, these latitudes change and the temperature is going to change. And so more sunlight hits the equator because the Earth isn't exactly, first of all, a sphere. Okay, it's kind of bulging at the equator. And also it is tilted. So there's this 23.5 degree tilt to the Earth. And so because of the tilt and the fact that, it's kind of bulging at the equator, that's going to lead to warmer temperatures near the equator, and more sunlight is able to hit the equator than any other place on Earth. So the surface of the Earth is being heated unevenly. So these areas are getting less sunlight, and these areas here are getting more sunlight, and then that changes as you kind of go across this band. And so as the Earth is being heated unevenly, what you end up what you end up getting are these climate differences in unique biomes. So the reason why there's more life on land, any other place on Earth, and even in the ocean, near the equator is because you have more residual heat that's able to be trapped because the Earth's rays, the sun's rays are hitting the equator more prevalently. And yes, that leads to climate differences. That's also why the North and South poles are so, cold. Last but not least, we have heat transport. And so heat transport happens as a result of this uneven heating of the Earth and the rotation of the Earth, right? You have this uneven heating where this area is warmer and these areas up here and down here are cooler, and the Earth is rotating around in circles. And as it does that, that means that the heat that is being, kind of trapped by these greenhouse gases is being moved. And as it's being moved around, we get these wind and we get these ocean currents, which are transporting heat all over the surface of the Earth. So what are the effects of climate change and how does that work? Well, the greenhouse gases that we just talked about, the CO2, the H2O, and the water look like this. This is water, this is CO2, and this is CH4. They only make up about 2.54% of the atmosphere by volume, and definitely by mass, they're even smaller. So these gases can absorb UV and visible light, and they retransmit that as heat. And so you can picture this as being a wave of some UV and visible light. This is a CO2 molecule. This is what it does when UV or visible light hits it. It starts to shake. And as it shakes like this, it is releasing infrared light in the form of heat. And so this kind of is a good diagram of how the greenhouse effect really works. This is what greenhouse gases are doing. Their bonds are vibrating, the molecules, the elements in the molecule are vibrating, and that's what's creating this heat. So the concentration or amount of greenhouse gases varies based on the region and the time. And so global surface temperatures have been changing. I didn't even know there was music on this. Global concentrations of these greenhouse gases have been changing over time. And they've been increasing, and the surface temperature on Earth has also been increasing. And so, as you can see here, we have some pretty dramatic differences in the average temperature difference on Earth over time. So, what is kind of global warming? Well, it is when these increased surface temperatures are caused by these greenhouse gases. That's what people are talking about when they talk about global warming. And so the mean temperature over the land and ocean has been increasing over time. And yes, again, notice we have these, great periods of where everything's cooler and some littler ones over here. But as time goes by, things are trending upwards. And we have, there were greater temperature differences of highs and lows a little bit further back. So what is climate change then? It is the result of global warming. And so changes in precipitation patterns, droughts, heat waves and floods, all of those over time could potentially be the result of climate change. Hurricanes becoming more frequent. Again, that has to do with precipitation patterns and heat. Sea level rising, Arctic ice melting, coral bleaching, ocean acidification. All of these things are kind of what climate change is all about. And climate change is the result of this increased greenhouse gas emission, which is now trapping more heat over the surface of the Earth. All right, so I hope you found that helpful. If you have any questions, let me know.